on the GI plane. That is between the GGSN and then the PDN. Now, let's move on to the second part of the network, which is the EPC network, right? The Evolved Packet Core network. The Evolved Packet Core network is made up of a main node, which is the MME, okay? So the MME is the mobility management entity and is the key control node in the Evolved Packet Core network, okay? So what does it do? It handles the non-access stratum signaling, which means that if ever you hear this term non-access, it means that the kind of signaling which is transparent to the access network, meaning that the access network does not interfere with this kind of signaling. It's a kind of signaling that moves from the users in the GSM network here all the way to the core network without it being interfered in the RAN network. So, I mean, some of these functions are like the attach, an attached message, a detached message, security functions are all non-access signaling. So the RAN network is just transmitting this network. It does not interfere, he does not add, he does not subtract. It is just transparent to the RAN network. All it does is to be able to transfer or transmit that message from the GSM user to the core network. The same for the WCDMA. Okay, so we have non-access stratum signaling, which I've just described. Then selection of PGW and then SGW, right? So we'll talk about the PGW, that's a packet and PDN gateway and then the 7 gateway, okay? Now, how does the subscriber or know which of these nodes to be able to talk to, okay? Is being handled by the MME, right? Now, the next function of the MME is the reachability of the UE in idle mode. So basically, I mean, it handles the mobility management, which is here, in the sense that if a subscriber is idle, he's not transmitting or receiving packets in the Evolved Packet Core network, he goes into a state called the idle mode. In that state, what happens is, if a subscriber has to be reached, he has to be paged, okay? So in paging that subscriber, right, that is what we are talking about, the reachability, making sure that we are able to reach that UE in the idle mode, and it's handled by the MME. Then the tracking area or TA list management, right, is also being handled by the we will talk more about it tomorrow. TA is just the tracking area whereby we've subdivided the whole PLMN or the whole packet core network into small areas. So a subscriber moving in between these tracking area lists, right, would have to inform the network when he moves to a new location. So that is also being handled by the MME. And MME selection also selects for handovers the MME change. So for example, I'm moving from one MME to another MME, right? That communication will be handled by the anchor or the 7 MME towards the next MME that I would want to move on to, or the next handover. So let's say I want to do an S1 handover, or I want to do the X2 handovers are normally not being handled by the MME. But when it comes to the X1 handovers, you find it being handled by the MME, which we'll talk about in the module 3. Module 3 will talk more about the signaling and then the flows that happen within the network. So the same things, SGSN selection for handover for 2G to 3G access networks, okay? Then mobility management, which we've talked about. So moving from one location to another location, the UE has to update the MME that, hey, I'm in this new location, kindly note my location. That is being handled. Authentication, bearer management, and then lawful interception of signaling traffic. This function is a very, very important function for governmental agencies, whereby they want to know the type of traffic that is being sent to and from subscribers in order for them to intercept it and make sure that there are no security related threat messages that are being sent. Okay, so being able to get wind of cool uprisings and things like that will be able to be done by this function called the lawful interception of signaling traffic. Okay, so for most networks, this is compulsory. Okay, so these are the functions of the MME. Now we can see that the MME is just like the SGSN, but then without the traffic handling aspect. Okay, so what really happened? What really happened? Now, this SGSN here, right, was what they broke into two different parts. They called one part the MME, which will only handle the signaling in the network. So now they are trying to follow what is happening in the CS core network. The CS core network also used to be one network. We didn't have service application layer, call control layer. We didn't have the connectivity layer. It used to be one node. So one node, that's the MSC, was handling everything. Then later on, they broke that MSC into two different nodes called the MSC server and then the media gateway. So in the same vein, they are trying to migrate that analogy to the packet core network, whereby the SGSN was broken down into two different nodes in the evolved packet core network. So we have the MME handling the signaling aspect of the network, mobility management, authentication, bearer management, paging of the network is being handled by the MME. Then the traffic handling aspect of the network, right, is the SGW, right? So the SGW is what handles the traffic of the network that is towards the access part of the network. That is the part that connects to the node B for traffic is the SGW. So is this one node in the GPRS, that is the former network, that is the predecessor network to now that we have the EPC network, right, which has evolved to the EPC network, right? So the former network had one node called the SGSN, which was handling both signaling and traffic. Then in the evolved packet core network, what they did was that they broke that node into two different nodes, one called the MME and the other called the SGW. But what has happened is, because the SGW and the PGW are both traffic handling nodes, right? What has happened is that they have put these two nodes, most of the network have put, of the vendors have put these two nodes as one node. Because these two nodes, that's the SGW and the PGW, which we'll learn about in the next slide, are all handling packets. One is handling packet towards the PDN, that is the external network. The other is handling packet towards the user or towards the access network. Okay, so these two nodes, SGW and PGW, have been grouped as one node. Okay, they have been put together as one special node, which will learn, which would depend. Some networks, some vendors call it EPG, others call it it depends on the vendor and however they want to call it. You understand? But the primary thing is that in the EPC network, we have two main traffic handling nodes. We have the SGW, which is a breakaway of the SGSN for traffic. And then we have the PGW, which is in the GGSN. So it is the same GGSN here, which has migrated to the PGW in the EPC network. So sometimes in a network, you have the same node handling the SGW, the PGW, and then the GGSN, right? Because these three nodes are the packet handling nodes for the packet core network. This is handling packets, purely packets. SGW is also handling packets, pure packets. PGW is handling packets. So in the same vein, they've put these nodes as one node. So you have the SGW, PGW, and then the GGSN residing in one node. I mean, just to reduce the having a lot of nodes in a network, it's better to put sometimes the nodes that are functioning, having the same functions, but then depending on where they are connecting to, it's sometimes wise to put these nodes together as one. So GGSN, SGW, and PGW, even though there are 7 different aspects of the network, 2G, 3G, and then 4G respectively, they are put together as one node. So the SGW routes and forwards the user packet data from the UE to the PGW and from the PGW to the UE. Okay, somebody is coming in. Let me admit this person. Just a moment. Okay. All right. So we have the SGW. Who is this again? That's why it's good that join. Hello, please. Please ensure that your internet connectivity is good. If the internet connectivity is poor, you'll be logging in and out of the session, and it will be interrupting our flow. So just make sure that your internet session, your internet connectivity is very good, so that you will not be logged in and out of the meeting or the training. Okay. So below you find the functions of the SGW, functioning as a local mobility anchor for inter-inode B handover, mobility anchor for inter-3GPP mobility, supporting inter-operator charging based on subscriber and QoS QCI granularity, accounting for inter-operator charging that's based on GTP, S5, and then X8. We will talk about that in the module 2 when we are talking about the protocols and interfaces. Then supporting transport level packet marking for uplink and downlink. I mean, set the DSCP for QoS. Then support packet routing and transfer, packet performing lawful interception. Okay, so as I told you, the SGSN has that functionality whereby you can intercept traffic. You can know what is being sent through to and from a subscriber, to be able to pick up very sensitive security related information. Okay, so this aspect is being handled by the governmental agencies, which I already mentioned. Now, all that I mentioned above is, anchoring the transport or the user traffic from the user towards the PGW, making sure that we are being charged correctly, and then also making sure that the packets that we are sending in and out of the packet core are being marked. Now, in the packet core, we have something we call the QoS. QoS is the quality of service, whereby packets are given markings in order for us to be able to give priority to these packets. Okay, so we give priority to the packets so that in case of congestion in the network, we will be able to manage these packets very well. We'll be able to drop the ones that are not given so much high priority, and those that have high priority are being kept in the connection. All right. So basically, one node that handles that aspect of QoS is the SGW. Then we have the PGW. So the PGW is a user plane anchor for different access networks for non-3GPP networks towards the PDN, right? So connection towards the PDN functions as a gateway of the EPC and terminates the SGI interface bound for PDN. So here we will find the same uses, the same functionalities that we'll find in the SW being replicated here, but then here we'll find additional functionalities such as IP addressing allocation for UEs. Okay, that's one main function of the PGW, like the GGSN. So I told you that the GGSN is just the same node that migrated or that was upgraded to a PGW. Okay, and both of these nodes, GGSN and PGW, have the same functionality. It's just that one is being used in the GPRS network, the other is being used in the EPC network. And one main function of the PGW is the allocation of the UEs. Then the last node of discussion is the HSS. The HSS, like the HLR, is the database holding the subscription information of UEs that have subscribed to the EPC network. Okay, so as I told you before, the HLR has connection to the AUC. The same thing applies here. We have the HSS having connection to the AUC. The AUC stores the authentication algorithms, quintuplets, the triplets for authentication, making sure that any user that is going to use the subscriber network will be authenticated. Okay. Now, apart from authentication, you can also provide roaming restriction. You can provide barring services, provide restrictions over access types. And then one thing about HSS, unlike its predecessor node HLR, which supports the MAP or the mobile application protocol, this node supports the diameter. Okay, so we will talk about it more hopefully tomorrow. At this juncture, I would like us to take a little break. The next course will start, the IMS course will start. Let me see. IMS is from 11 to 12. Okay, so we have 15 minutes. Let's take a little short break. Then we'll come back at 11:05. Now it's 10:47 a.m. GMT. So, which is 11:47 in Nigeria and in Algeria. So we'll come back at 11:47 GMT, which will be 12:47 GMT. We'll come back and then we'll continue with the IMS network, which will finalize for the core network. So what we are going through are the different aspects of the core network. That's the CS. I've talked about the CS already. Now the PS, and then now we are talking about the IMS. We'll be talking about the IMS network. Yeah, so let's go for a short break. If you have anything that you misunderstood, you didn't understand well, and please do well to let me know. Just share in the message board your areas, or you can, if you don't want to go to break and you want to be vocal about your question, you can go ahead and ask your question because I'm still connected. All right, so if you want to go ahead and ask any questions, please, you can do that. Just feel free. Don't feel shy. Don't feel, just feel free. Ask any question that bothers you, and I'll be ready to support you to make sure that you understand what we are trying to portray or teach. So feel free. If you have any questions, you can go ahead and ask.